Here we go with solving equations. Equations are mathematical statements that have an equal sign in them. It's using algebra to basically state a puzzle, and we want to know what the value of the number is at the end. Let's take this first equation, x plus 2 equals 7. This equation is a way of saying, I'm thinking of a number, I add 2 to my number, and then the answer is 7. So if that's a true statement, then what number am I thinking of? Most of you would figure out that the answer is 5, and we write this as x equals 5. The big question I want to know is, how do we get the answer x equals 5 without guessing? And the way we do this is by undoing operations. Now we want to know what x equals. Now let's forget about the 7 for a minute and look at the left-hand side. LHS always stands for left-hand side of the equation. So that's everything on the left-hand side of the equal signs. If we look at the statement x plus 2, we have to realise how that's made. If we want to know what x is, okay, if we add 2, we get x plus 2. So I've drawn this up arrow showing you to get from x up to that statement, you have to add 2. Now we know from the question that the right-hand side of the equation, that's what RHS stands for, right-hand side, is equal to 7. Now there's a very basic rule that whatever you do to one side of the equation, you have to do to the other. But I'm going to flip that a bit and say, okay, if going up is plus 2, then going down will be the opposite of that, which is minus 2. So if we forget about the left-hand side for a minute and just look at the right-hand side, then 7 minus 2 is 5. And now we have solved the equation. In other words, x equals 5 is the solution. Now let's clean this up a bit. For your working, this is all you really need to write. I'm a fan of using arrows to show what happens on the left when you go up and down on the right. But maybe I'm a bit weird. Most people like to show what happens going down on both sides. Or without the arrows, it just looks like that. And after a little while, you learn to leave those out altogether. Though there's nothing wrong with showing them. Okay, now, you do have the option of checking your answer when you're finished. To do the check, what you do is put the answer back into the equation. So if I get rid of the x and put the 5 there instead, because remember x is the same as 5, so that should be fine, I can see that it works. 5 plus 2 is equal to 7, so x must be equal to 5. Now, a quick reminder about inverse operations. These are the operations that undo other operations. So, as we've seen, we undo plus with minus. Example, plus 7, we undo plus 7 with minus 7. Plus 10 with minus 10. Plus 43.2 with minus 43.2. And of course, we undo minus with plus. We undo multiply with divide. And divide in equations looks like a fraction. And we undo divide with multiply. Now let's have a look at this equation. 4b equals 100. Now again, the name of the game is to find out the value of b. What is b equal to? Focusing on the left-hand side, we remember that 4b means 4 times b. So if we want to start here, to get from b to 4b, we have to multiply by 4. So b times 4 is 4b. Now that we understand that, and we know that the right-hand side is equal to 100, if it's multiplied by 4 going up, it must be divided by 4 coming down. So without having to do any guesswork, we find quite confidently that b is equal to 25. And to check that, we put 25 instead of b back into the equation, and we get 4 times 25, because 4b means 4 times b, and 4 times 25 is 100, so that makes us happy. Alright, this one, k over 7 equals 3. I like to think of the equation as an if statement, and then all the working are a series of then statements. So what is k over 7 anyhow? We've got to remember that written as a fraction like that, it means k is divided by 7 to produce this term called k over 7. So now looking at the right hand side, to undo the divided by 7, we have to multiply by 7, and 3 times 7, 21. If we want to check that, we put the answer back into the equation. So instead of k over 7, we're saying 21 over 7. And what's that equal to? 3. Remember that once you know what you're doing, you really only need this. Sometimes it's better just to look at the equation and figure out what the missing number is. This is called solving by inspection. So we say to ourselves, 20 take away what is 4? 20 take away 16 is 4, so n has to be 16. Now, why can't we do that easily using our inverse operations? You can, but it's very difficult, because to get this phrase 20 minus n, starting with n, first you have to multiply by the number -1 to turn n into -n, and then you have to add 20 to get 20 minus n. On the way down, that would be minus 20, and 4 take away 20 is -16. Then you would have to divide -16 by -1 to get the correct answer of n equals 16. But that's a lot harder than just looking and figuring it out. Don't need any of that. Boom, 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 boom. That's the way to do it. In the next screencast, we will look at these two-step equations. Bye for now.